When we have a domain restriction on a rational function, one possibility for how that manifests on the graph is that we'll see a vertical asymptote at that domain restriction. The steps to find the vertical asymptotes are: number one, to completely factor the numerator and the denominator and simplify it, writing it in its lowest terms, meaning that if we have any common factors top and bottom, those will need to be canceled out. After that simplify step, the zeros of the factors that remain in the denominator will be the location of the vertical asymptotes. So let's look at two quick examples. We're asked to find the equations of the vertical asymptotes, and our first step is going to be to factor everything completely, the top and the bottom. The numerator is linear and therefore prime, but the denominator factors into x plus 4 times x plus 1. Let's recall that when finding the domain, we want to look at the domain restrictions before we simplify. So before we continue to find the vertical asymptotes, let's take a moment to look at the domain restrictions. We see that x cannot be equal to -4 and x cannot be equal to -1. Both of these values would cause the output to be undefined, and therefore they are both domain restrictions. If we were asked to find the domain in interval notation, we would start off at -infinity and go to -4, leave out -4 and continue to -1, leave out -1 and then continue on to positive infinity. However, to find the vertical asymptotes, we want to go ahead and simplify this rational function. When the factors x plus 1 cancel out, we are left with 1 over x plus 4, but notice this is not equal to the original function until we impose the domain restriction that was lost in the simplify step. The original rational function had these two domain restrictions, and therefore the rational function that it simplifies down to being must also have these same domain restrictions. Now, this domain restriction was lost in the simplify step, but this domain restriction is still in the problem. The domain restriction that remains through the simplify step is going to be where the vertical asymptote is located. So the vertical asymptote for this rational function is going to be at the vertical line x is equal to -4. Now -1 is also a domain restriction, but we don't get a vertical asymptote there. This element is removed from the domain by making a hole in the graph. We're going to get a hole in the graph at the zero of any factor that was lost in the cancel step. But we get a vertical asymptote at the zeros of the factor that remained through the simplify step. Let's see that again. So when finding the domain and the vertical asymptotes, the first thing that we need to do is to factor everything top and bottom. So we have x plus 2 times x plus 1 in the numerator and x plus 2 times x minus 2 in the denominator. Before we simplify, let's make note of our domain restrictions. We see that x cannot be equal to -2 and x cannot be equal to +2. If we were asked to state the domain, it would be from -infinity to -2, leaving out the -2, and then going to +2, leaving out the +2, and then continuing on to positive infinity. We identify the domain restrictions before we simplify. In order to identify the vertical asymptotes, we want to go ahead and simplify the rational function, which means to cancel out the factors of x plus 2. What we have left is going to be x plus 1 over x minus 2, but remember, this simplified version has to have the same domain restrictions as the original in order to be considered equal to the original. So since we lost the domain restriction, x is equal to -2 in the simplify step, we have to manually impose that restriction to ensure that our simplified version is now equal to the function that we started with. When we start graphing rational functions, what we'll see is that the domain restriction that remains through the simplify step is where the vertical asymptote is going to be located. So the vertical line x is equal to 2 is going to serve as somewhat of a fence or a boundary, preventing us from allowing x to be equal to 2. But the domain restriction that we lost in the simplify step, that is removed from the graph by making a hole in the graph at that x value. So there are two ways to remove elements from the domain. One is by making a vertical asymptote there, and the other is by making a hole.